Oke, halo selamat pagi. Perkenalkan kami dari kelompok 7, kelompok Elektronika Analog. Pada kesempatan kali ini akan memaparkan mengenai tugas yang telah kami kerjakan. Boleh di next? Oke, untuk kelompok 7 sendiri ada Abdul Rohid dengan NRP 027, saya sendiri Rian Fahrulloji dengan NRP 031, lalu ada Emri Riyandi dengan NRP 047, serta ada Mohammad Raihan dengan NRP 063. Untuk materi pertama, Emri, silakan.
Pertama adalah BCD bias operation. BCD bias operation, transistor biasing is the process of setting a transistor DC operating voltage or current condition to the correct level so that any AC input signal can be amplified correctly by the transistor. Necessary of transistor biasing. First point is to active and transistor biasing is essential. Second, for proper working, it is essential to apply voltages of correct polarity across its two junctions. If it not biased correctly, it would work inefficiently and produce distortion in the output signal. Third point is key point is not middle output, signal is distorted and the signal is flipped. Next. BJT bias operation is a bipolar junction transistor consists of two back p-n junction who share a thin common region with Vp. Contacts are made to all two regions. The two outer regions called the emitter and collector and the middle region called the base. The structure of an NPN bipolar transistor is shown in figure 5.2.1 or A. The device is called bipolar since its operation involves both types of mobile carrier, electrons and holes. Next. The operation of the device is illustrated with figure B in the previous slide. We consider here only the four active bias made of operation, obtained by four biasing the base emitter junction and reverse biasing the base collector junction. To simplify the discussion further, we also set VCA. Now, the corresponding energy band diagram is shown in figure C. Electron diffuse from the emitter into the base and hole diffuse from the base into the emitter. This scalar diffusion is identical to in a p-n junction. However, what is different is that the electron can diffuse as minority carriers through the quasi-neutral base. Once the electron arrive at the base collector depletion region, they are swept through the depletion layer due to electric field. This electron contribute to the collector current. In addition, there are two more currents. The base recombination current, indicated on figure J by the vertical arrow, and the base emitter depletion layer recombination current ER.D. Next.
So, the next one is dead zone. Crossover distortion produces a zero voltage, or what we call flat spot or deadband, on the output wave shape as it crosses over from one half of the waveform to the other. The reason for this is that the transition period when the transistors are switching over from one to the other does not stop or start exactly at the zero crossover point, thus causing a small delay between the first transistor turning off and the second transistor turning on. This delay results in both transistors being switched off at the same instant time, producing an output wave shape as shown on the graph on the right side. We can see in this graph that the circle area is the crossover distortion. Next slide, please. Okay. In order that there should be no distortion of the output waveform, we must assume that each transistor starts conducting when its base diameter voltage rises just above zero. But we know that this is not true because for silicon bipolar transistors, the base voltage must reach at least 0.7 volt before the transistor starts to conduct, thereby producing this flat spot. We can see, excuse me, the previous page, please. In this graph, we can see that this rectangular area in the middle of the red graph, we call it as the dead zone. Okay, next. So crossover distortion occurs in Class B amplifiers because the amplifier is biased at its cutoff point. This then results in both transistors being switched off at the same instant time. By applying a small base bias voltage, either by using a resistive potential divider circuit or diode, biasing this crossover distortion can be greatly reduced or even eliminated completely. The application of a biasing voltage produces another type or class of amplifier circuit commonly called as a Class AB amplifier. Then the difference between a pure Class B amplifier and an improved Class AB and an improved Class AB amplifier is in the biasing level applied to the output transistors. And therefore, we can say that the Class AB amplifiers is a Class B amplifier with bias. Next.
It is a Q point of a diode. Q point are the operating point of a device, also known as a bias point. Our question point is the steady state. These voltages are current at a specific terminal of an active device such as diode or transistor with no input signal applied. Also, the Q point is the relationship between the diode forward voltage and current defined by the device characteristic. Consequently, there is only one point on the current load line where the diode voltage and current are compatible with the circuit condition. In other words, this operating point or Q point is the intersection where the optimum forward voltage and forward current converge, and it is also the point where the diode operates at its optimum. The importance of a Q point to circuit operation. Another way of expressing a Q point is by addressing it as biasing. Biasing in electronic means establishing predetermined voltage or current at various points of an electronic circuit to promote proper operating condition in electronic component. Numbers of electronic devices, including diodes, transistor, and even vacuum tubes, whose function is processing time-varying as signal also require a steady DC current of voltage to operate correctly. Furthermore, when supplying the AC signal, you do so by superimposing it on the DC bias current or voltage, whereas a bias circuit is a portion of the device circuit which supplies this steady current or voltage. In summary, the Q point is essential to a component's the other are circuit's overall functionality.
Alfa dan beta transistor. Parameter transistor alfa dan beta mewakili penguatan saat ini, jika juga dikenal sebagai rasio transfer arus maju. Dari transistor BJT, parameter ini dan rumus terkait digunakan dalam perhitungan semikonduktor. Dalam konfigurasi basis umum transistor NPN, arus kolektor IC adalah input dan arus emitor IE adalah output. Oleh karena itu, rasio IC or IE adalah DC alpha. Dalam dokumentasi transistor alpha dan beta berbagai rumusnya, hubungannya sangat sederhana ini, yang biasanya berguna dalam perhitungan semikonduktor umum. Next. Oke, terima kasih atas perhatiannya. Kami dari kelompok 7 Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.